Niggli has done his PhD at ETH Zurich, has been working in several agro research institutes before he actually became the head of FIBEL. FIBEL, that's the research institute, the Swiss Research Institute on Organic Agriculture, and he has been the head of FIBEL for 30 years. And I think in the beginning there were 20 people, today there are 300 people, so he really shaped this institute, and he also shaped organic agriculture in general, not only in Switzerland, I think in Europe, maybe even worldwide. You are in several commissions today, you're in several board members, and actually it's my great pleasure to have you here to tell us more about agroecology, because I think agroecology is one of the concepts that will help us to bring agriculture, but also maybe urban water and wastewater management together. And actually, I think it's one of the really promising approaches how to close the nutrient cycle and to ensure nutrition for the whole population in the future. I'm really looking forward to your presentation.
Thanks a lot, Kai. For me, it's also a huge pleasure to be here because already since 1 p.m. this afternoon, I learned a lot from colleagues, from PhD students here, and it's exactly what I always wanted to know, but never dared to ask. So for me, it is also again a very fruitful afternoon to be here. So thanks a lot for that. I want to talk a little bit about agroecology, a way forward, transformation, because at the moment everybody talks about transformation, especially in agriculture. What do we have to transform? Why do we have to transform? What is the direction of transformation? Because agriculture on all levels, from farmers to scientists, they have been aware of many problems during the last 30 years. But now it seems that the agricultural movement really gets into speed for a transformation. The first picture here already shows everything. This is what is meant maybe with agroecology. It's with GPS, with satellites, with machinery, with sensor, a designed new landscape, agricultural landscape. So biodiversity comes back instead of monotony. So this is in a way the thinking of agroecological farming. I happened to be in Bonn the last 2 days for a new organization where I'm one of the scientific experts, Right for Water. This is an organization financed by the mineral water companies. And in these 2 days, I have already learned a lot about about drinking water, about deep drinking water, about different sources of pollution. So this had been a very good preparation for today's meeting. So the slogan of this club is to make the invisibles visible and to protect groundwater and also the deep groundwater. And so we discussed a lot about a lot of things. And for me, the most interesting point was a talk about Eleanor Claire Ostrom, the Nobel laureate of 2009. she developed a theory that a collective management of common goods is possible, and water is a common good. And because in many cases we see that where many people are responsible, nobody is really responsible. That's like in the kitchen of a Wohngemeinschaft, where nobody really feels responsible. So, and this is a problem also in how we manage our natural resources, because nobody is really responsible for it, nobody takes care, and this Elinor Ostrom developed a theory that there are also historical examples where a multitude of actors take responsibility over common goods and take care of it. One example she described was the Lake of Constance, the Bodensee, where all the actors surround the different monasteries, but also the different communities took care not to overfish the Lake of Constance, and over centuries they were able to organize that. So, and in the case of water, this was for me a very motivating example. The challenges we have at the moment is that on one hand we will have a food gap by 2050 of about 50. These are FAO figures of about 56%. So we need that much more food in 2050, and converting this additional need for food, for calories and protein, it would become necessary to convert 600 million hectares of land for agricultural production, meaning 400 million hectares more grassland and 200 million hectares more cropland. So, and these are disastrous figures for our environment and for the safety of the planet. Already now, we see the problem that for many indicators of the planet's stability, we are already in the red zone of a high risk, and with additional agricultural land we need in the future, this will become disastrous, as I already said. And one outcome of the time where I was a member of the scientific group of the United Nations Forum for Food Systems, the conference took place in 2021, was that we need an absolute stop of converting more natural vegetation, natural land, and rainforest examples, for example, into agricultural land. A wonderful example why this is so important, that we stop expanding agricultural land for food production and feed production, is because it has a tremendous impact on our environment. And a wonderful example is the Cuvette Centrale in the Democratic Republic of the Congo. They wanted to train a huge moorland with the size of 40% of Germany. It is the biggest moorland in Africa, and it's a beauty in terms of biodiversity, and of course, if you train that like we did it in Switzerland in the last century and the century before the last century, the result would be the most fertile soils for agriculture. So the government of the Democratic Republic of Congo, they dreamed of becoming the corn belt of Africa, producing and exporting a lot of food. And a lot of scientists, but also a lot of European government intervened, because such a conversion towards agricultural land would have released the greenhouse gas emissions of the United States produced during the last 20 years. So the Paris goal could become forgotten. And in addition, it would have destroyed a wonderful biodiversity. You can maybe have a glimpse here with these pictures. So this is quite an important example how more agricultural land could become essentially harmful for the global development. And unfortunately, what I heard in the last 2-3 months is that the government, which is not a democratic government, they restarted again with the idea to drain these wetlands. So we are not yet at the end of the story. So this dramatically shows how important it is that we manage the existing agricultural land both in a sustainable and in a productive way. And this is the challenge we face. So there are still a lot of land which has not been well managed by farmers in the past. For instance, a lot of former grassland which has been destroyed by grazing animals, so that the soil started to erode. And so, for instance, that we know exactly what a sustainable grassland management is. In Europe, we have quite a good situation, and Switzerland is one of the promoters of sustainable grassland management, meaning that this technique could be easily transformed to regions in the world where sustainable grassland management is not yet established. So we have such reserves which could become again fertile. This is an important step towards producing more food without expanding the agricultural land area. I talked about sustainable management of existing agricultural land, which will become very important. And if we look at all these methods for sustainable land management, you see many solutions, and you also see many conflicts between solutions. So the industry way is to use improved technologies like minimum and no tillage with GMO crops and with glyphosate. So this is partly a European but also an American way and of becoming more sustainable. And of course, green parties, NGOs, they oppose against the idea that this kind of management has a higher sustainability. But then also IPM, integrated pest management, all kind of precision or smart farming, low input agriculture in developing countries, or low external input sustainable agriculture in developing countries are strategies to become more sustainable. And then there are a few methods which pretend to be more sustainable, like organic farming, regenerative conservation agriculture, ecological intensification, agroecological practices, agro-silvopastoral systems, or successional agroforestry system. You see, these are listed in an order from having a low impact on sustainability and a high impact on sustainability. So often there are many conflicts. For instance, organic farmers are completely opposed to the idea of no-tillage systems with GMO crops and with Roundup, and so on and so on. So these debates are ongoing, but many concepts are available. We can choose and we can test, we can try, we can apply, and we can transform farmers towards one of these concepts. In my opinion, what I learned after 30 years of being responsible for, having been responsible of research for organic farming, is that under a wider term, agroecological farming, we can reunite different effective ways of becoming more sustainable in order to help to achieve the SDGs. And I listed them here again, and the last 2 points are very important in my opinion, is that under the term agroecology, it is not so strict like organic farming, where a lot of things are banned and a lot of things are allowed. And so the idea of agroecology is to look at the direction of the conversion and to look on externalities, sustainability impact with sustainability impact, so to permanently improve the system and not to apply one system with quite a narrow with narrow restrictions for organic agriculture. So the use of modern technologies such as digitalization, for instance, may support agroecological concept. At the end, I will also discuss whether modern breeding technologies like genome editing could help to establish sustainable agroecological systems. And agroecology is best described as a smart combination of traditional knowledge, which is very important, especially in developing countries, like in Africa, for instance, and in Latin America. There is a tremendous wealth of traditional indigenous knowledge, which helps the farmer to run their farms in a very sustainable way. And so the combination of traditional knowledge, of farmer experience, which is permanently augmented, the best use of the ecological context of interaction with the local ecosystems, and technical innovation. So this is, in a way, my definition of agroecology. And technical innovation, in case it helps sustainability, and it has a good balance, or it has it doesn't harm our environment and human health, then technical innovation is also welcome in agroecological farm practicing. So looking at literature, and we did that especially in the preparation of the UNFSS 21, is that there is one central mechanism which is common to a lot of studies in literature, is that we can correlate positively productivity with the maintenance of ecosystems and resource maintenance via the factor diversity. So diversity, it is not integrated farming, organic farming, or any technical way or management. It is always the common between high productivity and high resource maintenance, natural resource maintenance, is always productivity, diversity, sorry. And here are only three literature mentioning and explaining the context, but the scientific opinion on that, it is clear. We need to go towards higher diversified farming and food systems to have all these positive effects. You can have the PowerPoint slides later on if you're interested. And diversification includes everything. So it is the diversification of landscape, the diversity of actors, farmers, breeders, farm advisors, scientists. So in countries where you lose all the breeders and have monopolies by one breeding company, you have a tremendous loss of diversity of knowledge, but also of genetic resources. So the diversity of actors is a very important aspect. The diversity of knowledge, different sources of knowledge, is extremely important, and that's why it is tremendously important in developing countries to include, to empower female farmers, because their knowledge is extremely important. The diversity of value chains, short, local distribution channels, the diversity of farm activities is very important, mixed farming system combining livestock and crops, the diversity of crop rotation, of course, and the diversity of agroforestry system, mixed cropping system, intercropping, within field and soil diversity. This is a diversity of species and the biodiversity of microorganisms, and of course the diversity of crops and food we eat. This is especially important for our health system. So diversity is all what it is about. Solutions are always highly diversified. But then, how important is really the farming system? Sometimes I started to question why you always work for developing new farming systems. Because if, for instance, if you look at global aspects of the problems we run into, like greenhouse gas emissions, you can see here on the y-axis high input systems, and on the x-axis the low input farming system. Here especially organic versus conventional. Sorry. So here is the greenhouse gas emission for conventional production, and here are the greenhouse gas for organic production in kilogram CO2 equivalents per kilogram food. And what you see here is that between low input and high input, there is not a highly significant difference. But what you produce makes the difference. So these are under 2 kilogram CO2 equivalents per kilogram product. The green ones, these are all plant products, plant food. And then you have dairy milk, and then you have pig and poultry production, and here you have the ruminants, especially dairy cows. So basically what you eat makes a difference globally. And this might demotivate you to work for sustainable farming systems because it doesn't make a difference in terms of climate change. But of course, it can make a difference locally. And this global perspective and local perspective, this is very important to make a difference. And you might say now that we should stop to produce dairy milk and dairy and meat. But of course, this is not a solution because we have so much grassland globally and locally, which can only be converted to protein and to energy via dairy cows. So here we have a conflict which between food security and between sustainability and climate change, which cannot be avoided. So maybe we have to go a little bit deeper into sustainability. I think what is quite helpful to think in terms of sustainability in 3 narratives. One narrative is the efficiency narrative, and this is what is done at the moment by agricultural research. More input with more output with less input and less environmental footprint. But then you also have the consistency narrative, because, for instance, an alpine farmer can never be efficient, but he takes care of a beautiful landscape. So this is more a qualitative aspect which has nothing to do with efficiency, but it's still worthwhile to continue to manage such regions. So consistency means to have the best adaptation to territorial, cultural, and socio-economic context. Also, the term resilience is a consistency term, and also the cradle to cradle principle is a very important aspect, where you try to avoid any pollution during farming because you want to reuse the organic matter produced by farmers by composting again, and so the product you want to, the residues you want to produce compost should be completely free of chemical pollution. So that's why this qualitative aspect is also very important. That's completely different from what you do. You try to filter out all the pollution so that you can produce again a good product for recycling, but maybe that will come on farm level also one day, but at the moment it would be better to take care that you don't use pesticides, veterinary drugs, medicine, and so on, so that you have really a good quality of organic matter and residues. And then the sufficiency narrative is a very important one. So reducing consumption and waste, and reducing especially meat consumption, and you could also call it temperance, but this is not such a popular term, because temperance is you have to this sounds a little bit like you have to restrict yourself, but sufficiency has a more positive is a more positive term, but it describes the same: less meat consumption, reduce food waste, and these are the two most important aspects of sufficiency. And maybe this aspect for the further development of our food systems is much more important than any farming system. If we cannot control consumption, we will never achieve that our agriculture will become sustainable. And one of the problems nowadays is that it doesn't look like that people change the way they eat and they treat food waste. So this is, for instance, the production of pork and poultry, and the soybean area globally. The line is the soybean production, and pork and poultry. And you see, especially poultry production has a tremendous increase over the last 50 years. And the last figure is from 2020. And globally, you do not see any tendency towards a sufficient, a modest nutrient behavior, and also a reduction of food waste. So we still have an increase of meat consumption, a considerable increase of meat consumption globally. And it's clear that this kind of, I call it German diet, Bavarian diet, this has also a huge impact on the way you keep and you feed your animals. and an Italian or Mediterranean diet. It can also be a Turkish diet. This it has also an impact not only on the positive on the environment or a less negative, but it has also an impact on the way you breed and you feed your animals. So you see that via the diet you have a huge impact on environment, on animal welfare, and also, of course, on human health. This is basically the way forward, which is extremely important. And I want to show you as a case study organic agriculture, and here we can see what the problems and the challenges are. So the European Union, they started 3 years ago with the farm to fork strategy, and within that strategy they formulated one goal, that was to having 25% organic agriculture by 2030. That is in 8 years' time. And this is the current situation here. And this is the growth of organic needed till 2030 if the EU Commission wants to achieve that their own policy. And you can't see at the moment that this is happening. At the moment we see that this is happening because the inflation and the higher prices of food in general has stopped conversion towards organic. So this organic strategy is a very difficult strategy, and whether it can be achieved or not is at the moment not clear. And also, if you look at the market, the consequences of such a strategy on markets would be, the markets are here, 2019, and with 50 billion euros, and the growth needed to be like that in order to sell what you produce in such a scenario, to sell to consumers. And it's also not, at the moment, it's not realistic. What we know about organic farming is that, and we know that for instance, Switzerland, by the quite famous long-term comparison experiment in Switzerland, the dog trial run by FIBEL and by Agroecology together. And this is a scientific design of 1 hectare with a 7-year crop rotation running since 1978, and with different treatments like zero fertilization, biodynamic farming, organic farming, integrated farming, and conventional farming. So this experiment has delivered so many data that we have a clear understanding about what the impact of different farming methods on soils and on biodiversities are. And you see here the most important results for many indicators of, for instance, energy efficiency, nutrients efficiency, soil percolation stability, soil aggregate stability, abundance of beneficial insects, earthworm biomass, microbial biomass, enzyme activities of the microbes, mycorrhiza, energy efficiency of microorganisms, weed diversity and yields. And you see the organic treatments, they have all a very positive effect on all these indicators by 50% plus 100%. The zero line is the integrated treatment where you still use pesticides, but you can see, and this is only with fertilized by mineral fertilizers. So it's a stockless system where no animals are there. And you see that by only using organic fertilizer, on-farm organic fertilizer, that all these parameters profit tremendously. So it's not only the organic, but also it's the organically fertilized conventional system. And that's why I think it's very important that we bring organic manure into or any kind of organic component into farming systems. The only negative aspect of organic is that you have about 20% lower yields. And here again, the same systems with biological indicators, organic matter content, microbial biomass, and mycorrhiza. And you see here the difference. This is the biodynamic system. And, but you also see that a conventional system where you add organic manure, where you recycle what you have from animal systems, that it comes close to the best organic system, the biodynamic farming system. So the differences are not so huge, also here and also here. And where you have IPM systems with no organic matter recycling, you see that it's considerably lower. So also here, the dominant effect here is also the recycling, the combination of animal production and of plant production. But nonetheless, this higher soil biology, higher biological activity has a certain impact on the physical properties of soil. And you see here after heavy rainfalls, I think that was in 97, wasn't it? 2002. That was really an extraordinary rainfall. And this is this is the conventional farming system directly during the rainfall, and this is after a little bit later on. So you see you have the soil aggregate stability on the surface has been completely destroyed. And this is the biodynamic treatment where the infiltration goes faster and the soil can take up a lot of water, and then what it looks like after a week later. So still an excellently structured soil surface. So you see here that already these tiny differences in soil biology have a positive impact of physical properties of soil. That's why organic is quite a good local strategy. And you can see the same if you look at birth diversity of the abundance of birds. So here is the lapwing, Kibitze, and here are the skylark, the Feldlerche. You see that, and that was measured in the United Kingdom and in Scandinavia, where they have entire areas where they have a lot of organic farms, and can compare it to area where they have conventional farms. And you see here that the number of birds per 10 hectare has doubled, and also the same here with skylark. So a local effect compared to a global climate change is a global effect. There you see no big difference between conventional and organic farming, but local effects are also very important if you focus on this natural food nets. And because, for instance, pesticide can cause a lot of disruption. So, and this is also can be shown by a lot of literature. So here, organic can have a very positive impact. The negative one is that the productivity in terms of yields is a huge challenge for organic farming, and these are many comparing trials around the world. So organic yields versus conventional yields. And you can see here that the more productive the site, the field is, the bigger the yield differences grow in very productive areas, like in the northern part of Germany towards the Baltic Sea. And there you have the highest cereal yields in Europe. And there the difference between organic and conventional systems can be up to 50% more or less yields. And in marginal areas, like here where you have lower yields, you can see that the difference between conventional and organic is irrelevant. So this is a challenge for organic farming, and in my opinion, it's the only challenge. And my colleague, Adrian Müller from the ETH and also working at FIBL, he calculated how much arable land would be needed if you convert huge parts of the world towards organic. And you can see here that depending on different climate change developments, zero impact of climate change on agriculture productivity, medium and high impact of climate change on agriculture productivity, that if you for each scenario they modeled from 0 to 100% organic. And you can see here that with growing negative impact of climate change on productivity, you need much more agricultural land to produce the same amount of food for a growing population. Here it goes up to 71%. And you can react by reducing food waste from 0 reduction to 25 to 50%. This is what FAO recommends, and you can also reduce the competition between animal production and human nutrition by reducing the feedstuff production by 0, 50, and 100%. And if you have a medium effect of climate change on yields, you can, and if you have a tremendous reduction of cereal production for feed for animals, and you have a reduction of food waste, then also with organic scenario, you can feed the world without using more arable land. But these cases won't happen, unfortunately. And we will be here somewhere here, and so an upscaling of organic farming system will only be possible by reducing the feedstuff for animal production and by reducing food. These combinations are essential for the further development of organic farming. Another strategy which is very much promoted are vegan diets. Can we solve all the problems by not eating meat and not drinking dairy milk? And this is also an unrealistic scenario. Eating less meat is very important. That's why the vegan movement is very important. But eating no meat is completely impossible because 2/3 of our agricultural land is grassland. Either 50% is permanent, you cannot plow, you cannot produce crops, and about 15% of the global area we have grassland in the crop rotation, where we need grass clover so that the soil can regenerate. We can not only grow cereal after cereal after cereal, so we have to let the soil recover by grass and clover in the rotation. So we have to use this kind of grassland to feed the world. So this is an important future scenario, but it's alone, it cannot solve the problem. It is the same case for organic. It is very important to take care of the local resources, but alone it cannot feed the world. And so these, because we know exactly that leguminous crops provide twice more, 2 times more protein than milk and 20 times more than meat. This is the positive thinking, but we cannot replace the meat because of the high protein quality, and we need to use the grassland, and we also need to use the byproducts of cereals out of the processing industry, like bran, press cake, hummus, etc., etc. So I don't go into that. And so also plant-based meat won't be a solution, because here we also need the scarce resource of arable land, which is tremendously scarce globally. Although these plant-based burgers are fantastic in their quality, I love them, and we might better use novel foods. Here I'm very positive about, for instance, insects for protein. Crickets here, the example. My wife has already ordered several times from Google these crickets, and they are terrible, but they give a very good conscience. I see more chances, and this is then your job, by micro and macro algae, because here that is a tremendous resource for food production, which has not yet used. And one scientist calculated that if you put the land area of Portugal on the sea and you produce their algae, then you could feed the entire world. So this is a tremendous resource, which makes me very positive. We might also debate about accelerating breeding, plant breeding or animal breeding via the new genome editing techniques. This is also a potential which the society has to decide whether they want to use it or not. They are ready to be used. And then I don't go, now it's time to stop, isn't it? So the agroecological transformation is a multi-level transformation, and it includes making farming systems so resilient, that is step 3, that the farm doesn't need any more inputs as fertilizers or as pesticides. And that would be the best thing for water quality and for environment quality. But it also includes the consumer, because any further development of farming systems are only possible in cooperation with consumers. This will become the most challenging thing. And finally, sustainable farming systems need a paradigm shift also in our society. So that was it. So.
Okay, thank you very much, Urs. So it was a little bit longer, but most people are still here, so it was really interesting. And I would like to open the floor actually for questions here and also at Zoom. So please raise